prepared by Marwa, Afifi, Luciana, Aguirre, and Mackenzie Miller as a requirement for ME 168 at San Jose State. The topic of this presentation is microchannel gradients. We are going to cover two examples of real-world applications, the different types of macrochannel gradients, a few examples of geometries of microchannel gradients, and lastly, our conclusions. Real-world applications. As we can see in this image, there are three light concentration generators. They use sets of serpentine channels to improve mixing of the two fluids. The concentration generator is then attached to an array of the cell culture chamber. The cells will start to spread and attach on the surface of the electrode, which will block the flow of the current of the opposite direction. The testing agent and dilution solution will travel in between cells and also between the cell and the electrode. The goal of this to have a better understanding in the adhesion characteristics of the cell and cell electrode. Also, it will provide more information to obtain the optimum dosage. Describes a technique that facilitates anti-solvent crystallization. As we can see it in the image, there are three inlets, two for the anti-solvent and one for the solution. Once the solutions mix, they start to form crystals along the microchannel. This provides a localized concentration gradient of solute and anti-solvent, which can be used for the formation and better modification of molecular crystals.
Of the compositions in solutions are used mostly in biochemical and chemical applications like cancer chemotaxis, bacteria growth, or optimization of reaction conditions. As we can see in the image, the concentration gradient is showing different concentrations. Gradients of the physical chemistry on the surface show the bacteria growth or complex protein structures. The external environment is also important and therefore temperature gradients are necessary. Here we can see how the PDMS substrate has a gradient of the pore and polymer globule size. In solution show how the shear stress can have a major effect on the cell arrangement migration and migration rate. This picture here shows the substrate wall and different shear stresses. Gradients of refractive index in solution can be used for optofluidic lenses produced by glycol solutions with a refractive index. Of geometry in microchannel gradients is the use of serpentines. This adds length to the channel and the curves increase mixing. In this image, the solution is mixed and then separated again to go through another set of serpentines. Another example is the use of dividers, which creates a physical barrier within the channel, therefore creating a gradient in the microchannel. Show how you can use diffusion to create a gradient with two different solutions. The image on the left uses inlets on opposing sides where the solutions diffuse in a channel connecting them. The image on the right uses inlets on the same side, forcing mixing to occur where the solutions meet. This also creates a concentration gradient within the microchannel. Microchannel gradients can be useful in many fields of study. With so many different options as discussed here, the field of study are unlimited. However, this can make choosing the type of gradient generator difficult. Choosing the right gradient generator requires careful consideration of experimental needs to be able to obtain the desired outcome. By using a microfluidic gradient, we can obtain precise gradient control on a small scale. Here are a list of references we used for our presentation. Thank you for listening.